You are listening to Audio SSLC, your audio medium for easy understanding and revision. To download a copy of this recording, please visit audiosslc.com.
Chapter 14 Sources of Energy. In Class 9, we learned that the total energy during a physical or chemical process is conserved. Why then do we hear so much about the energy crisis? If energy can neither be created nor destroyed, we should have no worries. We should be able to perform endless activities without thinking about energy resources. This riddle can be solved if we recall what else we learned about energy. Energy comes in different forms, and one form can be converted to another. For example, if we drop a plate from a height, the potential energy of the plate is converted mostly to sound energy when it hits the ground. If we light a candle, the process is highly exothermic, so that the chemical energy in the wax is converted to heat energy and light energy on burning. What other products are obtained when we burn a candle? The total energy during a physical or chemical process remains the same. But suppose we consider the burning candle again. Can we somehow put together the heat and light generated along with the products of the reaction to get back the chemical energy in the form of wax? Let us consider another example. Suppose we take 100 ml of water which has a temperature of 348 K or 75 Celsius and leave it in a room where the temperature is 298 K or 25 Celsius. What will happen? Is there any way of collecting all the heat lost to the environment and making the water hot once it has cooled down? In any example that we consider, we will see that energy in the usable form is dissipated to the surroundings in less usable forms. Hence, any source of energy we use to do work is consumed and cannot be used again. What is a good source of energy? What can then be considered a good source of energy? We, in our daily lives, use energy from various sources for doing work. We use diesel to run our trains. We use electricity to light our street lamps, or we use energy in our muscles to cycle to school. Activity. List 4 forms of energy that you use from morning when you wake up till you reach the school. From where do we get these different forms of energy? Can we call these sources of energy? Why or why not? The muscular energy for carrying out physical work, electrical energy for running various appliances, chemical energy for cooking food or running a vehicle all come from some source. We need to know how do we select the source needed for obtaining the energy in its usable form. Activity. Consider the various options we have when we choose a fuel for cooking our food. What are the criteria you would consider when trying to categorize something as a good fuel? Would your choice be different if you lived A. in a forest, B. in a remote mountain village or small island, C. in New Delhi, or D. lived 5 centuries ago? How are the factors different in each case? After going through the 2 activities above, we can see that the particular source of energy or fuel we select for performing some work depends on many different factors. For example, while selecting a fuel, we would ask ourselves the following questions. 1. How much heat does it release on burning? 2. Does it produce a lot of smoke? 3. Is it easily available? Can you think of 3 more relevant questions to ask about a fuel? Given the range of fuels we have today, what are the factors which would limit our choices when it comes to a particular task like cooking our food? Would the fuel selected also depend on the work to be done? For example, would we choose one fuel for cooking and another for heating the room in winter? We could then say that a good source of energy would be one, which would do a large amount of work per unit volume or mass. It would be easily accessible. It would be easy to store and transport. And perhaps most importantly, it would be economical. Questions. 1. What is a good source of energy? 2. What is a good fuel? 3. If you could use any source of energy for heating your food, Which one would you use and why? Conventional sources of energy. Fossil fuels. In ancient times, wood was the most common source of heat energy. The energy of flowing water and wind was also used for limited activities. Can you think of some of these uses? The exploitation of coal as a source of energy made the Industrial Revolution possible. Increasing industrialization has led to a better quality of life all over the world. It has also caused the global demand for energy to grow at a tremendous rate. The growing demand for energy was largely met by the fossil fuels, coal and petroleum. Our technologies were also developed for using these energy sources. But these fuels were formed over millions of years ago, and there are only limited reserves. The fossil fuels are non-renewable sources of energy, so we need to conserve them. If we were to continue consuming these sources at such alarming rates, we would soon run out of energy. In order to avoid this, alternate sources of energy were explored. But we continue to be largely dependent on fossil fuels for most of our energy requirements. Figure 14.1. Burning fossil fuels has other disadvantages too. We learned in class 9 about the air pollution caused by burning of coal or petroleum products. The oxides of carbon, nitrogen, and sulfur that are released on burning fossil fuels are acidic oxides. These lead to acid rain, which affects our water and soil resources. In addition to the problem of air pollution, recall the greenhouse effect of gases like carbon dioxide. The pollution caused by burning fossil fuels can be somewhat reduced by increasing the efficiency of the combustion process and using various techniques to reduce the escape of harmful gases and ashes into the surroundings. Besides being used directly for various purposes in gas stoves and vehicles, do you know fossil fuels are the major fuels used for generating electricity? Let us produce some electricity at our own small plant in the class and see what goes into producing our favorite form of energy. Activity. Take a table tennis ball and make 3 slits into it. Put semicircular fins cut out of a metal sheet into these slits. Pivot the tennis ball on an axle through its center with a straight metal wire fixed to a rigid support. Ensure that the tennis ball rotates freely about the axle. Now connect a cycle dynamo to this. Connect a bulb in series. Direct a jet of water or steam produced in a pressure cooker at the fins. Figure 4.2. What do you observe? This is our turbine for generating electricity. The simplest turbines have one moving part, a rotor blade assembly. The moving fluid acts on the blades to spin them and impart energy to the rotor. Thus, we see that basically we need to move the fan, the rotor blade, with speed which would turn the shaft of the dynamo and convert the mechanical energy into electrical energy. The various ways in which this can be done depends upon availability of the resources. We will see how various sources of energy can be harnessed to run the turbine and generate electricity in the following sections. Thermal power plant. Large amount of fossil fuels are burnt every day in power stations to heat up water to produce steam, which further runs the turbine to generate electricity. The transmission of electricity is more efficient than transporting coal or petroleum over the same distance. Therefore, many thermal power plants are set up near coal or oil fields. The term thermal power plant is used since fuel is burned to produce heat energy, which is converted into electrical energy. Hydropower plants. Another traditional source of energy was the kinetic energy of flowing water, or the potential energy of water at a height. Hydropower plants convert the potential energy of falling water into electricity. Since there are very few waterfalls which could be used as a source of potential energy, hydropower plants are associated with dams. In the last century, a large number of dams were built all over the world. As we can see from figure 14.1, a quarter of our energy requirement in India is met by hydropower plants. In order to produce tidal electricity, high-rise dams are constructed on the river to obstruct the flow of water and thereby collect water in larger reservoirs. The water level rises, and in this process, the kinetic energy of flowing water gets transformed into potential energy. The water from the high level in the dam is carried through pipes to the turbine at the bottom of the dam. Figure 14.3. Since the water in the reservoir would be refilled each time it rains, hydropower is a renewable source of energy. We would not have to worry about hydroelectricity sources getting used up the way fossil fuels would get finished one day. But construction of big dams have certain problems associated with it. The dams can be constructed only in a limited number of places, preferably in hilly terrains. Large areas of agricultural land and human habitation are to be sacrificed as they get submerged. Large ecosystems are destroyed when submerged under the water in dams. The vegetation which is submerged rots under anaerobic conditions and gives rise to large amounts of methane, which is also a greenhouse gas. It creates the problem of satisfactory rehabilitation of displaced people. Opposition to the construction of Tehri Dam on the river Ganga and Sardar Sarovar project on the river Narmada are due to such problems. Improvements in the technology for using conventional sources of energy. Biomass. We mentioned earlier that wood has been used as a fuel for a long time. If we can ensure that enough trees are planted, a continuous supply of firewood can be assured. You must also be familiar with the use of cow dung cakes as a fuel. Given the large livestock population in India, this can also assure us a steady source of fuel. Since these fuels are plant and animal products, the source of these fuels is said to be biomass. These fuels, however, do not produce much heat on burning, and a lot of smoke is given out when they are burnt. Therefore, technological inputs to improve the efficiency of these fuels are necessary. When wood is burnt in a limited supply of oxygen, water and volatile materials present in it get removed, and charcoal is left behind as the residue. Charcoal burns without flames, is comparatively smokeless, and has a higher heat generation efficiency. Similarly, cow dung, various plant materials like the residue after harvesting the crops, vegetable waste, and sewage are decomposed in the absence of oxygen to give biogas. Since the starting material is mainly cow dung, it is popularly known as gobar gas. Biogas is produced in a plant as shown in figure 14.4. The plant has a dome-like structure built with bricks. A slurry of cow dung and water is made in the mixing tank, from where it is fed into the digester. The digester is a sealed chamber in which there is no oxygen. Anaerobic microorganisms that do not require oxygen decompose or break down complex compounds of the cow dung slurry. It takes a few days for the decomposition process to be complete and generate gases like methane, carbon dioxide, hydrogen, and hydrogen sulfide. The biogas is stored in the gas tank above the digester, from which they are drawn through pipes for use. Biogas is an excellent fuel as it contains up to 75% methane. It burns without smoke, leaves no residue like ash in wood, charcoal, and coal burning. Its heating capacity is high. Biogas is also used for lighting. The slurry left behind is removed periodically and used as excellent manure, rich in nitrogen and phosphorus. The large-scale utilization of bio-waste and sewage material provides a safe and efficient method of waste disposal, besides supplying energy and manure. Do you think that biomass is a renewable source of energy? Wind energy. We saw in class 9 how unequal heating of the landmass and water bodies by solar radiation generates air movement and causes winds to blow. This kinetic energy of the wind can be used to do work. This energy was harnessed by windmills in the past to do mechanical work. For example, in a water lifting pump, the rotatory motion of windmill is utilized to lift water from a well. Today, wind energy is also used to generate electricity. A windmill essentially consists of a structure similar to a large electric fan that is erected at some height on a rigid support. Figure 14.5. To generate electricity, the rotatory motion of the windmill is used to turn the turbine of the electric generator. The output of a single windmill is quite small and cannot be used for commercial purposes. Therefore, a number of windmills are erected over a large area, which is known as wind energy farm. The energy output of each windmill in a farm is coupled together to get electricity on a commercial scale. Wind energy is an environment-friendly and efficient source of renewable energy. It requires no recurring expenses for the production of electricity. But there are many limitations in harnessing wind energy. Firstly, wind energy farms can be established only at those places where wind blows for the greater part of a year. The wind speed should also be higher than 15 km per hour to maintain the required speed of the turbine. Furthermore, there should be some backup facilities like storage cells to take care of the energy needs during a period when there is no wind. Establishment of wind energy farms requires a large area of land. For a 1 megawatt generator, the farm needs about 2 hectares of land. The initial cost of establishment of the farm is quite high. Moreover, since the tower and blades are exposed to the vagaries of nature like rain, sun, storm, and cyclone, they need a high level of maintenance. Questions 1. What are the disadvantages of fossil fuels? 2. Why are we looking at alternate sources of energy? 3. How has the traditional use of wind and water energy been modified for our convenience? Alternative or non-conventional sources of energy. With technological progress, our demand for energy increases day by day. Our lifestyles are also changing. We use machines to do more and more of our tasks. Our basic requirements are also increasing as industrialization improves our living standards. Activity. Find out from your grandparents or other elders. A. How did they go to school? B. How did they get water for their daily needs when they were young? C. What means of entertainment did they use? Compare the above answers with how you do these tasks now. Is there a difference? If yes, in which case more energy from external sources is consumed? As our demand for energy increases, we need to look for more and more sources of energy. We could develop the technology to use the available or known sources of energy more efficiently and also look to new sources of energy. Any new source of energy we seek to exploit would need specific devices developed with that source in mind. We shall now look at some of the latest sources of energy that we seek to tap and the technology designed to capture and store energy from that source. Solar energy. The sun has been radiating an enormous amount of energy at the present rate for nearly 5 billion years and will continue radiating at that rate for about 5 billion years more. Only a small part of solar energy reaches the outer layer of the Earth's atmosphere. Nearly half of it is absorbed while passing through the atmosphere, and the rest reaches the Earth's surface. Activity. Take 2 conical flasks and paint one white and the other black. Fill both with water. Place the conical flasks in direct sunlight for half an hour to 1 hour. Touch the conical flasks. Which one is hotter? You could also measure the temperature of the water in the 2 conical flasks with a thermometer. Can you think of ways in which this finding could be used in your daily life? A black surface absorbs more heat as compared to a white or a reflecting surface under identical conditions. Solar cookers, figure 14.6, and solar water heaters use this property in their working. Some solar cookers achieve a higher temperature by using mirrors to focus the rays of the sun. Solar cookers are covered with a glass plate. Recall what we have learned about the greenhouse effect. Does this explain why a glass plate is used? Activity. Study the structure and working of a solar cooker and/or a solar water heater, particularly with regard to how it is insulated and maximum heat absorption is ensured. Design and build a solar cooker or water heater using low-cost material available and check what temperatures are achieved in your system. Discuss what would be the advantages and limitations of using the solar cooker or water heater. It is easy to see that these devices are useful only at certain times during the day. This limitation of using solar energy is overcome by using solar cells that convert solar energy into electricity. A typical cell develops a voltage of 0.5 to 1 volt and can produce about 0.7 watts of electricity when exposed to the sun. A large number of solar cells are combined in an arrangement called solar cell panel, figure 14.7, that can deliver enough electricity for practical use. The principal advantages associated with solar cells are that they have no moving parts, require little maintenance, and work quite satisfactorily without the use of any focusing device. Another advantage is that they can be set up in remote and inaccessible hamlets or very sparsely inhabited areas in which laying of a power transmission line may be expensive and not commercially viable. Silicon, which is used for making solar cells, is abundant in nature, but availability of the special grade silicon for making solar cells is limited. The entire process of manufacture is still very expensive. Silver used for interconnection of the cells in the panel further adds to the cost. In spite of the high cost and low efficiency, solar cells are used for many scientific and technological applications. Artificial satellites and space probes like Mars orbiters use solar cells as the main source of energy. Radio or wireless transmission systems or TV relay stations in remote locations use solar cell panels. Traffic signals, calculators, and many toys are fitted with solar cells. The solar cell panels are mounted on specially designed inclined rooftops so that more solar energy is incident over it. The domestic use of solar cells is, however, limited due to its high cost. Energy from the sea. Tidal energy. Due to the gravitational pull of mainly the moon on the spinning earth, the level of water in the sea rises and falls. If you live near the sea or ever travel to some place near the sea, try and observe how the sea level changes during the day. This phenomenon is called high and low tides, and the difference in sea levels gives us tidal energy. Tidal energy is harnessed by constructing a dam across a narrow opening to the sea. A turbine fixed at the opening of the dam converts tidal energy to electricity. As you can guess, the locations where such dams can be built are limited. Wave energy. Similarly, the kinetic energy possessed by huge waves near the seashore can be trapped in a similar manner to generate electricity. The waves are generated by strong winds blowing across the sea. Wave energy would be a viable proposition only where waves are very strong. A wide variety of devices have been developed to trap wave energy for rotation of turbine and production of electricity. Ocean thermal energy. The water at the surface of the sea or ocean is heated by the sun, while the water in deeper sections is relatively cold. This difference in temperature is exploited to obtain energy in ocean thermal energy conversion plants. These plants can operate if the temperature difference between the water at the surface and water at depths up to 2 kilometers is 20 K, that is 20 Celsius or more. The warm surface water is used to boil a volatile liquid like ammonia. The vapors of the liquid are then used to run the turbine of generator. The cold water from the depth of the ocean is pumped up and condensed vapor again to liquid. The energy potential from the sea, that is tidal energy, wave energy, and ocean thermal energy, is quite large, but efficient commercial exploitation is difficult. Geothermal energy. Due to geological changes, molten rocks formed in the deeper hot regions of Earth's crust are pushed upward and trapped in certain regions called hotspots. When underground water comes in contact with the hotspot, steam is generated. Sometimes hot water from that region finds outlets at the surface. Such outlets are known as hot springs. The steam trapped in rocks is routed through a pipe to a turbine and used to generate electricity. The cost of production would not be much, but there are very few commercially viable sites where such energy can be exploited. There are a number of power plants based on geothermal energy, operational in New Zealand and United States of America. Nuclear energy. How is nuclear energy generated? In a process called nuclear fission, the nucleus of a heavy atom, such as uranium, plutonium, or thorium, when bombarded with low-energy neutrons, can be split apart into lighter nuclei. When this is done, a tremendous amount of energy is released if the mass of the original nucleus is just a little more than the sum of the masses of the individual products. The fission of an atom of uranium, for example, produces 10 million times the energy produced by the combustion of an atom of carbon from coal. In a nuclear reactor designed for electric power generation, such nuclear fuel can be part of a self-sustaining fission chain reaction that releases energy at a controlled rate. The released energy can be used to produce steam and further generate electricity. The major hazard of nuclear power generation is the storage and disposal of spent or used fuels. The uranium still decaying into harmful subatomic particles, that is, radiations. Improper nuclear waste storage and disposal result in environmental contamination. Further, there is a risk of accidental leakage of nuclear radiation. The high cost of installation of a nuclear power plant, high risk of environmental contamination, and limited availability of uranium makes large-scale use of nuclear energy prohibitive. Nuclear energy was first used for destructive purposes before nuclear power stations were designed. The fundamental physics of the fission chain reaction in a nuclear weapon is similar to the physics of a controlled nuclear reactor. But the two types of device are engineered quite differently. Activity. Discuss in class the question of what is the ultimate source of energy for biomass, wind, and ocean thermal energy. Is geothermal energy and nuclear energy different in this respect? Why? Where would you place hydroelectricity and wave energy? Questions 1. What kind of a mirror, concave, convex, or plane, would be best suited for use in a solar cooker? Why? Question 2. What are the limitations of the energy that can be obtained from the oceans? Question 3. What is geothermal energy? Question 4. What are the advantages of nuclear energy? Environmental consequences. We have studied various sources of energy in the previous sections. Exploiting any source of energy disturbs the environment in some way or the other. In any given situation, the source we would choose depends on factors such as the ease of extracting energy from that source, the economics of extracting energy from the source, the efficiency of the technology available, and the environmental damage that will be caused by using that source. Though we talk of clean fuels like CNG, it would be more exact to say that a particular source is cleaner than the other. We have already seen that burning fossil fuels causes air pollution. In some cases, the actual operation of a device like the solar cell may be pollution-free, but the assembly of the device would have caused some environmental damage. Research continues in these areas to produce longer-lasting devices that will cause less damage throughout their life. Activity. Gather information about various energy sources and how each one affects the environment. Debate the merits and demerits of each source and select the best source of energy on this basis. Questions 1. Can any source of energy be pollution-free? Why or why not? Question 2. Hydrogen has been used as a rocket fuel. Would you consider it a cleaner fuel than CNG? Why or why not? How long will an energy source last us? We saw earlier that we cannot depend on the fossil fuels for much longer. Such sources that will get depleted someday are said to be exhaustible sources or non-renewable sources of energy. On the other hand, if we manage biomass by replacing the trees we cut down for firewood, we can be assured of a constant supply of energy at a particular rate. Such energy sources that can be regenerated are called renewable sources of energy. Renewable energy is available in our natural environment in the form of some continuing or repetitive currents of energy, or is stored in such large underground reservoirs that the rate of depletion of the reservoir because of extraction of usable energy is practically negligible. Activity. Debate the following two issues in class. A. The estimated coal reserves are said to be enough to last us for another 200 years. Do you think we need to worry about coal getting depleted in this case? Why or why not? B. It is estimated that the sun will last for another 5 billion years. Do we have to worry about solar energy getting exhausted? Why or why not? On the basis of the debate, decide which energy sources can be considered. 1. Exhaustible. 2. Inexhaustible. 3. Renewable. And 4. Non-renewable. Give your reasons for each choice. Questions. Number 1. Name 2 energy sources that you would consider to be renewable. Give 2 reasons for your choices. Question 2. Give the names of 2 energy sources that you would consider to be exhaustible. Give reasons for your choices. What you have learned. 1. Our energy requirements increase with our standard of living. 2. In order to fulfill our energy requirements, we try to improve the efficiency of energy usage and also try and exploit new sources of energy. 3. We also need to look for new sources of energy because the conventional sources of energy like fossil fuels are in danger of getting exhausted soon. 4. The energy source we select would depend on factors like the ease and cost of extracting energy from the source, the efficiency of the technology available for using that source of energy, and the environmental impact of using that source. 5. Many of the sources ultimately derive their energy from the sun. Exercises. 1. A solar water heater cannot be used to get hot water on A. A sunny day, B. A cloudy day, C. A hot day, or D. A windy day. 2. Which of the following is not an example of a biomass energy source? A. Wood, B. Gobar gas, C. Nuclear energy, or D. Coal. 3. Most of the sources of energy we use represent stored solar energy. Which of the following is not ultimately derived from sun's energy? A. Geothermal energy, B. Wind energy, C. Nuclear energy, or D. Biomass. 4. Compare and contrast fossil fuels and the sun as direct sources of energy. 5. Compare and contrast biomass and hydroelectricity as sources of energy. 6. What are the limitations of extracting energy from A. The wind, B. Waves, C. Tides? 7. On what basis would you classify energy sources as A. Renewable and non-renewable, B. Exhaustible and inexhaustible? Are the options given in A and B the same? 8. What are the qualities of an ideal source of energy? 9. What are the advantages and disadvantages of using a solar cooker? Are there places where solar cookers would have limited utility? 10. What are the environmental consequences of the increasing demand for energy? What steps would you suggest to reduce energy consumption?